Hi, welcome back. This round we look at the Common Test June 2012 Common Test paper, revision question 4. Now question 4 shows us a circuit of 3 elements in series: the resistor, the inductor, and the capacitor. So let me try and outline this. We have the resistor, we have the inductor, and we have a capacitor, all connected in series with an AC voltage applied and the current flows IT. So we have R, L, and C. Alright, and we are given that R is equals to 200 ohm. The inductance impedance is J 250 ohm, and the capacitive impedance is minus J 100 ohms. And we have the voltage across the resistor VR, we have voltage across the inductor VL, we have the voltage across the capacitor VC. Right. Now we are also told that the current, the I RMS, is 0.25 amps. Since that is a reference current, I should give this the 0 degree reference. Alright, so those are the information given to us, and we want to determine the following things. Number 1, we want to determine the total impedance in polar form. So total impedance ZT is given as the impedance of the resistor, the impedance of the inductance, and the impedance of the capacitance. So in phasor form, you can write it up. This way. (200) angle 0, since resistance does not introduce any phase shift. The inductance. Okay, since you already provided in the rectangular form, I shall leave it in the rectangular form. Plus J 250 ohms and minus J 100 ohms. So in rectangular form, it will be 200 plus J 150 ohms. Okay, that's rectangular form, so I convert that to polar form. There will be in polar form, it will come out as 250 at an angle of 36.87 degrees. Okay. Now next we want to calculate will be the source voltage. The voltage drop across the resistor, inductor, and capacitor. The voltage drop, or rather the supply voltage E, can be computed from I Z total. That's equals to 0.25 angle of 0 degrees multiplied by 250 impedance, the total impedance that we calculated in part 1. That gives us 62.5, the angle of 36.87 degree volt. Right? The voltage across R can be computed from I times ZR. That's equals to 0.25, the angle of 0 degrees, multiplied by the impedance, the resistance, which is equals to 50, angle of 0. Similarly, for the voltage across the inductor, we have I equals to ZL, that's equals to 0.25, an angle of 0 degrees, multiplied by ZL. ZL is given as 250 and an angle of positive 90 degrees. That gives us 62.5 plus 90 degrees. Finally, voltage across the capacitor I is C. This means 0.25 angle 0. Means 100 minus 90 degrees. That gives me 25 angle of minus 90 degrees volt. Okay, so those are the voltages and the various elements, the voltage drop. Next, we want to calculate average power consumed by the resistor. Average power consumed by the resistor. So power average by the resistor can be calculated as I squared of the R value. In this case, 0.25 squared times the resistance, 200. It gives us 0.25 times 200. Now, 0.5 volts. Finally, find the overall power factor of the circuit. Now, the overall power factor of the circuit is the cosine of the phase difference between the supply voltage and the current. Since the current is taken as a reference, current is 0, I mean it's angle 0. The voltage, supply voltage which we calculated is now at an angle of 36.87 degrees. Hence, the power factor is a cos of 36.87 degrees minus 0 degrees. That gives us 0.7999, so that's close to 0.8. Lagging. Why lagging? Because the voltage is leading the current. Right? We always look at the point from current, so in this case the current is lagging. Alright. And finally, the last part of this little thing is to sketch the phasor diagram for the voltage supply, the current coming in, the voltage across the resistors, and so on. So, in order to draw the phasor diagram is drawn as follows. We have the vertical axis, we have the horizontal axis. Now, current is the reference, so current will draw first. So current is I is an angle 0. The supply voltage E is an angle this way, so that E is equals to 36.87 degrees. the voltage across the resistor. The voltage across the resistor is in phase with the current, so this is VR. The voltage across the inductor is plus 90 degrees, so it should be going upward. It's VL, which is 90 degrees. And we have VC, which is going the other way, which is 90 degrees. Okay, here you are. This is the phasor diagram and the final answer to this question. Well, I hope you have learned something today. Bye-bye.